All right, on example 2, let f of x equal x to the fourth minus 2x squared. Find all values of c in the interval from -2 to 2 such that f prime of c is equal to 0. So this is exactly what I was talking about before. If I see something like this, f prime of c is equal to 0, I want to make the association with Rolle's theorem. Okay, but in order to get to apply Rolle's theorem, we want to make sure that we can apply Rolle's theorem. Hey, what were the conditions for that thing? Remember, it needs to be continuous on a closed interval. And in this case, the closed interval is from -2 to +2. I know it gave it to us as an open interval, but it has to be continuous on the close. So there's the first thing. Is this function continuous on the closed interval? Yup, because you know why? It's polynomial. So if you do have to do something like this on the calculus exam, just point it out. Point it out that it's a polynomial function which is continuous everywhere, therefore it has to be continuous on this closed interval right here. Okay, so just connect that dot, and then we also want to connect another dot to say that it's differentiable on the open interval from -2 to 2. Well, again, since it's polynomial, we can say, hey, that's a check mark. There's one more condition. We have to make sure the endpoints are the same. In other words, I need to show that f of -2 is equal to f of +2. And you know what I'm going to do? Because it's one of my favorite things to do. It's synthetic substitution. Let's see what these y values are supposed to be. So x to the fourth, x cubed, there isn't one, x squared, x, and then the constant term. So don't forget your extra zeros here. So let's bring down the 1, multiply, -2, add it up, multiply, 4, add it up, 2, and then we get a -4, -4, 8, remainder of 0. Remainder of 8, which means that f of -2, of course, is 8 by the remainder theorem. And then let's do the same thing on +2. Okay, 1, 0, -2, 0, 0, 1, 2, yeah, that's right, 2, 4, 2, man, this is looking really familiar except for without positive and negative numbers, 4, 4, 8, oh yeah, there we go, so f of +2 is equal to 8, and our third condition has been satisfied. So we've got f of -2 is equal to f of 8, which is, no, that's not right. Come on. +2, which is equal to 8. Check, check, check. So we know Rolle's theorem is guaranteeing someplace in between -2 and +2, the slope's got to be equal to 0. So the derivative is equal to 0. We just need to find everywhere that happens. Let's do that, shall we? We'll have to do that by taking the derivative of this thing. Hey, wait, first let me write down the function again because I don't remember what it was. X to the fourth minus 2x squared. Now let's take its derivative. 4x to the third minus 4x to the first. And I need to set this thing equal to 0. Why am I setting it equal to 0? Because we're trying to see where the slope is equal to 0, right? Rolle's theorem, equal to 0. Slope, 4x cubed minus 4x. It is a cubic polynomial. Cubic polynomial, in order to solve it, you got to equal it to 0, which we already did. And then you got to factor it. This one's easy enough to factor because we can pull out a common factor of 4x. And then we would have an x squared minus 1 left behind, which means from right here, x is equal to 0. And then from right here, x squared minus 1 is equal to 0, so x squared is equal to 1, so x is equal to plus or minus 1. Okay, look at that. We have 3 values. Rolle's theorem is guaranteed at least one of them is supposed to be in that interval. And where was our interval? It was from -2 to +2. And it looks like actually every single one of ours is in that interval. Well, we lucked out. Like I said, Rolle's theorem is only guaranteeing one of them in there. We got all 3 of them in there. So let's see what that looks like here on this graph. So here's that graph, that quartic polynomial. And then here are the 3 points where we have those horizontal tangent lines between those two endpoints.